Hi, guys. I'd like to do an example in chapter 13 that hasn't been WebExed before, even though we've done similar problems. It does require some discussion. Let me share my screen. And go to the example I was requested to do, which is chapter 13, number 9. Let's go there. It's already open somewhere, I believe. Let's open it again. Okay, so here's the problem. We have a objective function, in this case to maximize, even though it's possible to have a minimization problem as well. The screen just went. Excuse me while I record, get back my screen. Okay, and we're first asked to find the feasible region. Well, I'm going to get back to that in a minute. But basically, because we have two constraints, basically you want to graph these straight lines, because again, this is the equation of a straight line. It can be expressed as y equals something times x plus another constant. And the second constraint, and technically these are constraints as well, that we want all the x's to be bigger than 0, the y's to be bigger than 0. So essentially, we're talking about this quadrant of the coordinate system, the xy plane. So how would you solve this? Well, one way is by finding, you plug in, pick a convenient x, like x equals 0. What is the corresponding value for y? Well, if x is 0, 400 times x is 0, and 2000 y equals 26,000. So divide 2000 into 26,000, and that gives you y equals 13. So the point 0 on the x, y equals 13 is one of the vertices, as they're called, or boundaries of the, and that's here, 0 and 13. Likewise, if x equals 0 equals 3y, y has to be 0. So 0, 0 is the second point. But it's that third point where these two lines intersect, which requires you to solve two equations and two unknowns that could be difficult. I mean, it involves some algebra and some multiplying, dividing, etc. All I know, there's something on the internet, I would guess there is, to help you solve that. But we really can solve that as well, and actually solve the whole problem in one shot by going back to the solver that we used to solve earlier examples in chapter 13, the linear programming. So I prepared that already. I had we've seen this before to solve homework 6, 7, 8, I believe, or 7 and 8. You list the name of the variables. I don't think this is important. Call it the variable information, also not important. But you start out with the values of 0 and 0. Likewise, the constraint. The first constraint is 400x plus 2000y, which is, you can see it up here, 400x 2000y is less than or equal to 26,000. The second constraint is 1x, or 1 times c1 minus 3 times c2 is equal to 0, less than or equal to 0. So 0 goes here and the constraint goes here. At this point, we're ready to go to the solver, which is found data, solver, and you tell it where the, where the objective is. Well, the objective function we haven't typed in yet, if you notice. So this can be left blank, because we're not trying to maximize something, we're trying to solve it. So instead of going to max or min, we try to find the values for the two lines intersect. The variables are found in C1 and C2. We said that before. It's right here. The constraints are, instead of having, when you add a constraint, or instead of having the constraint found in B4 compared to 2600, which is C4, instead of having a less than or greater than, now it's equal. Likewise, this one, this constraint would be equal. So then when you say solve it, we want to make sure this is non-negative because that we have to have only answers that are greater than 0. And we want to use the simplex method. Hit solve. It pops up. Oh, okay, so here's my problem. I guess we have to go back and this is equals. But I do wrong. Let's try it again. 26,000. Solver. Let's get rid of that. Now maybe that would work. Okay, so we can keep the solver solution, hit OK. Sometimes you like to get this stuff coming out also. You might need this for the previous examples where they asked you about the slack. I forgot to tell you that there, I believe, but this part of the problem tells you how much slack there is or if it's binding. Remember those problems in number 7 and number 8. Hit OK. It's chugging away, it's solving it, and here's the answer. Answer report. The optimum, really where they meet. X equals 24.375, Y equals 8.125, and that's the answer. Now the student didn't put down exactly those numbers, but it was still marked correct because I give some plus or minus 1 leeway when solving these things because it's a messy algebra. But technically it was wrong. But when that student plugged it into the objective function, to go back, because these numbers are off by a little bit, the objective was off by a lot because they multiplied by large numbers, 316, 810, and therefore was marked wrong, as you can see if I get this out of the way. This was marked wrong. The right answer was close because, so again, we just saw, disappeared of course, where'd it go? Where are we? Anyway, so getting back to, so this is how we identify the 3 vertices. We have a solution, which again, you change, the computer tells us is a slightly better answers. We want to maximize it. And this, oh, we haven't done that yet. Let's go back and do that. Gotta find it. Where is it? What happened to my Excel? Oh, there it is. It's down there. Okay, so let's go back to the sheet 1. And now we can add an objective constraint. Objective function, as it's called. And we can call it equals. I just saw it a second ago. It disappeared, of course. 360, 810. 360 times C1 plus 810 times C2. We now have an objective function. And because we already solved this equation, well, this is not really true. Let's go back and make the, because now we solved the equation in 2 unknowns, but we don't know, maybe some of the other vertices, maybe 0, 0 gives you a better value. Maybe 0, 13 gives you a better value. So let's make this back. Let's start again, so to speak. Data, solver. The objective function is now found in B3. Did that. We want to maximize. That's the problem tells you that. Variables are found in C1 and C2. We have to delete these objectives. Or what did I just do? I guess. Oh, change it. Let's change it. Instead of, now it's going to be less than or equal. Okay. Now we want to take this one and change it, make it less than or equal. Okay. Now we're in a position to solve it. And we hit OK. And this time we actually did get the 15,356.25 that book says is the right answer. Okay, I hope that helps. We'll add it to the list of WebExes, and good luck. Again, I hope you're accelerating some of your work because we're coming to the end of the term before you know it. Again, But keep those questions coming in and I'm happy to help.